We're going to go through this worksheet here, pre-calc trig review, solving trig equations. So with these problems, we're solving equations for theta and theta between 0 and 2 pi, 0 included, but less than 2 pi. So 31, 2 sine squared theta is equal to 1. We're trying to work towards getting theta by itself, but first we're going to try and get the sine squared theta by itself. So divide both sides by 2, we get sine squared theta equals 1/2. Take the square root, so plus or minus root 1/2 is equal to sine theta. And plus or minus 1 over root 2 is same thing as root 2 over 2. So sine of theta is going to be root 2 over 2. Plus or minus will be all the variations of pi over 4. So pi over 4 in all 4 quadrants. They all fall between 0 and 2 pi. 32, tangent squared theta is equal to 3. We're again working our way down to solving for theta. So first we're going to try and get rid of the square root. So we take the square root of both sides. Square root of tangent squared theta becomes tangent. The square root of 3 plus or minus square root of 3. Anytime we take the square root of both sides, we always include plus or minus. And tangent of theta is equal to plus or minus root 3. Those will be occurring at intervals at variations of pi over 3. So pi over 3 in the first quadrant, 2 pi over 3, 4 pi over 3, and 5 pi over 3. For 33, tangent squared theta minus tangent theta equals 0. We treat this like an algebraic problem through factoring. So we can factor a tangent theta out. Leaves us with tangent theta minus 1. It's equal to 0, so we can set both terms, both factors equal to 0. Tangent theta is equal to 0 at 0 and pi. Tangent theta minus 1 is equal to 0. So add 1 to both sides. Tangent theta is equal to 1 in the first and the third quadrant, so pi over 4 and 5 pi over 4. So we have 4 solutions, 0 pi, pi over 4, and 5 pi over 4. We do include 0 because our domain is including 0. Okay, greater than or equal to 0 and less than 2 pi. 34, 2 cosine squared theta minus cosine theta equals 1. We don't want to factor the cosine theta out yet because it's not equal to 0. Okay, we can't just factor cosine theta and say 2 cosine cosine theta parentheses 2 cosine minus 1 is equal to 1, and then set both parentheses equal to 1. This only works if the right side is equal to 0. So first thing we need to do is we need to bring the 1 over to the left side, and notice now we have 3 terms. Trinomial, we have to think of it in terms of a factoring problem. So think of it as 2x squared minus x minus 1. We can factor it as 2x plus 1 times x minus 1. And then replace the x back with cosine theta, and then now we have 0 on the right side. We can set both parentheses equal to 0. 2 cosine theta plus 1 is equal to 0. Cosine theta equals negative 1/2, which occurs, cosine is negative in the second and third quadrant, so 2 pi over 3 and 4 pi over 3. Cosine theta is equal to 1 at 0. Technically 0 and 2 pi, but we don't include 2 pi because of our domain restrictions. 35. Secant cosecant equals 2 cosecant. I'm going to convert everything to be in terms of sine and cosine. It's easier for me to think in terms of sine and cosine, just easier to work with. So I'll replace secant with 1 over cosine, replace cosecant with 1 over sine, replace 2 cosecant with 1 over 2 over sine. And we can multiply this together. And if we cross multiply, we get 2 sine cosine equals sine. Subtract the sine to the left side. Now we can factor out the sine. We're left with 2 cosine theta minus 1. Set both parentheses equal to 0. So sine theta equals 0. 2 cosine theta minus 1 is equal to 0. Theta is equal to 0. And cosine theta is equal to 1/2. We don't include 0 as a solution. Even though 0 falls between 0 and 2 pi, we have a restriction in terms of our original equation. If I plug 0 into the original equation, cosecant of 0 does not exist. basically 2 over sine of theta. 2 over sine of 0 is going to be undefined, so 0 is an extraneous solution, and we don't include that. Cosine theta is equal to 1/2 at pi over 3 and 5 pi over 3. 36 sine is equal to cosine. Whenever we see these types of problems, we can convert this to be in terms of tangent. So if I divide both sides by cosine, I get sine over cosine equals cosine over cosine. Cosine over cosine is 1. Sine over cosine is tangent. Tangent is equal to 1 in the first and the third quadrant, so pi over 4 and 5 pi over 4. 37, cosine squared theta plus sine theta is equal to 1. It's probably easiest to express this equation in terms of one function. So we do have an identity, Pythagorean identity that will allow us to convert between cosine and sine. I'm going to decide arbitrarily to convert everything to be sine. So cosine squared theta, we know cosine squared plus sine squared is equal to 1. So cosine squared is 1 minus sine squared. Replace cosine squared with 1 minus sine squared. And we're going to bring everything over to one side. Subtract 1 from both sides. The 1's cancel out. We can factor out a sine theta. And we get sine theta times 1 minus sine theta is equal to 0. Set both equal to 0. We get sine equal to 0. 1 minus sine theta is equal to 0. Sine is equal to 0 at 0 and pi. And sine theta is equal to 1 at pi over 2. 38, we have something that looks a little bit strange here, theta over 2. So to make things a little bit easier to work with, let's let x represent theta over 2, since we don't want to really deal with half angle identities if we don't have to. So let x represent theta over 2, just to make the initial process a little bit easier, and then we can convert everything back. So if 1/2 theta is x, then theta is going to be 2x, right? Since because of this relationship here. Also, if I cross multiply, I can see that relationship show up as well. 2x is equal to theta. So I know that theta can be replaced with 2x. So cosine x minus cosine 2x equal to 1. This is a little bit easier to deal with. We can recall double angle formulas easier than we can recall half angle formulas or identities. So if we have this scenario here, we can, since we already have cosine, we have a couple of variations to get cosine 2x out of double angle form, and the one that's going to make the most sense probably is going to be the one that involves cosine. So one variation of cosine 2x is 2 cosine squared x minus 1. So we're going to make that substitution. And we're going to bring everything over to one side, subtract the 1, the 1's cancel out, factor the cosine out, and we can solve for x. So cosine of x equal to 0 at pi over 2 and 3 pi over 2. 1 minus 2 cosine x, the same thing as cosine x equals 1/2. Cosine is 1/2 at in the first and fourth quadrants, so pi over 3 and 5 pi over 3. But we're not quite done yet because we solve for x, but we're trying to solve for theta. So we have to finish our problem here. So we know x is equal to, we have 4 solutions for x. However, we know x is theta over 2. So if I replace x with theta over 2, that's essentially multiplying everything through by 2 will allow me to solve for theta. So if I multiply everything through by 2, theta will be equal to pi, 3 pi, 2 pi over 3, and 10 pi over 3. However, we only want to keep the theta measures that are between or in our domain, and 3 pi and 10 pi over 3 are outside of our domain between 0 and 2 pi. So the only solutions that we're going to get are pi and 2 pi over 3.